Hello friends, welcome to Bhavesh Sir ki class. Today we are going to see video lecture and will enjoy your studies. Dear friends, welcome to the new session. Today we are going to see a very easy chapter. Before going into this chapter, I would just like to ask you, do you recall this particular concept? I have written down point P 3,2. If you have studied coordinate geometry in grade 9, this would be easier for you to mention that x coordinate of point P is 3 and y coordinate is 2. So you have to recall this particular concept and then only we can go forward into the topic which we are going to see. The green perpendicular lines which I have drawn represents the number lines, perpendicular number lines. Horizontal number line is called as x-axis. Vertical number line is called as y-axis. Where they meet each other is called as origin. Due to these two lines, the region is divided into four regions. Roman 1 is first quadrant, Roman 2 is second quadrant, third quadrant and fourth quadrant. Also, x-axis, that is line x dash and y dash are border lines. They are neither the part of any of the four quadrants. Now, if I look at point P, then it has two coordinates, as I say. Fine. One type of coordinate is called as abscissa and other is called as ordinate. Abscissa is nothing else but x coordinate and ordinate means y coordinate. Now, if the position of the point is in first quadrant, we will recall grade 9, grade 8, whatever we study, then abscissa will be positive, ordinate also will be positive. Point will be somewhere over here, anywhere in this region number 1. If point is in region number 2, what happens? Your abscissa, that is x coordinate, becomes negative and y coordinate remains positive. So this is the position if the point is in the second quadrant. So this column represents position of point. Either first quadrant, second quadrant, third quadrant or fourth quadrant. So if point is in third quadrant, then both its coordinates, that is abscissa as well as ordinate, will be negative. If point is in the fourth quadrant, that means it can be anywhere over this region, then its x coordinate will be positive and y coordinate will be negative. X coordinate is also called as abscissa and y coordinate is also called as ordinate. Now, apart from this four positions, point can lie either on x-axis or y-axis. So right now I am talking about x-axis. If point is on x-axis, that means it can be anywhere over here. Fine. So its x coordinate will be either positive or negative. It will be positive or negative and its y coordinate will always be 0. If it is on y-axis, then it becomes reverse, as its y coordinate can be positive, or its x coordinate will be 0 and its y coordinate will be positive or negative. Before going into the next topic, which is section and midpoint formula, we need to know these basic concepts as well as few more basic concepts which we are covering just now. Now we will try to understand few basic terminology. I have drawn a segment AB. Coordinates of point A are 3, 6 and coordinates of B are 7, 4. I state that point M bisects segment AB. I say point M bisects segment AB. Remember the term bisect. Bisect means divides exactly into two equal parts. In simple terminology, I can say that M is midpoint of segment AB. That is, AM will be equal to MB. Right now, I do not know the coordinates of point M, which I have mentioned as X and Y. Now, question is, find the coordinates of midpoint of segment AB. I'm repeating the question. Find the coordinates of point M, which is midpoint of segment AB. Now remember, it's pretty simple. If you want to find out coordinates of midpoint of a segment, then we are going to use by midpoint formula. X will be equal to X coordinate of first point plus X coordinate of second point, that is 3 plus 7 over 2, and Y coordinate will be 6 plus 4 over 2, that is I have added Y coordinate of A, Y coordinate of B, divided by 2. Why divided by 2? We have to understand this part also. Why divided by 2? Just now I mentioned that point M is midpoint of segment AB, or it divides segment AB into two equal parts. That is, it divides in the ratio 1:1. 1:1. And hence, one part plus one part, that makes two parts. One part plus one part, that makes two parts. Hence, whenever you want to find out the coordinates of midpoint, it's very simple. X coordinate of first point plus X coordinate of second point divided by 2. Same way, Y coordinate of first point plus Y coordinate of second point divided by 2. If I want to know the calculation part of this, it will be 10 over 2. And here, it will be 10 over 2. So, X will be equal to 5 and Y also will be equal to 5. So, coordinate of point P are 5, 5. That is your answer. Just now we saw the midpoint formula. Next part what we are going to see is called as a section formula. It is little difficult or little more complex compared to the midpoint formula. Now here I am having segment AB whose endpoints are A and B, having what their coordinates x1, y1, and B has a coordinates x2, y2. There is one point P on AB. It is not midpoint, remember, it is not midpoint, it is any point other than midpoint, and it is dividing segment in the ratio M1:M2. That means this much part is M1, this much part is M2. If in the previous example it was 1:1 ratio, here is ratio is M1:M2. That means it is other than 1:1. It can be 2:5, 3:2, any other ratio it can be. So the ratio is M1:M2. Point P divides segment AB in the ratio M1:M2. In such case, if I want to find out the value of X, how can I find out the value of X? Or if I want to find out value of Y, how can I find out value of Y? That is given by section formula. Here X will be equal to M1 into this part into. See, remember, M1 contains X1 as X. Both it is a part of its endpoints are containing X coordinate as X and X1. Other coordinate which is not related to M1 part is X2, so it will be multiplied to the other part plus M2 into M2 is related to X1, X as well as X2. It is not related to, or it is not touching X1, so M2 into X1 over M1 plus M2. Same way, if I want to find out Y coordinate, then your M1 remains M1, your M2 remains M2 over sum of the parts, that is M1 plus M2. M1 will be multiplied to Y2, that is M1 Y2, and M2 will be multiplied to Y1. So this is the section formula. It's pretty simple. I told you it is complex. Compared to midpoint formula, it is complex, but you can remember it very easily. And first exercise, that is exercise A, is entirely based on section formula, midpoint formula, and you have to recall some basic concept of distance formula. If you remember distance formula, last year you studied. If I want to find out distance AB, this is just a revision for you. It is nothing else but x1 minus x2 the whole square plus y1 minus y2 the whole square. Somebody can also write it down as x2 minus x1 the whole square plus y2 minus y1 the whole square. My dear friends, one important point you have to remember whenever they ask distance, and if you are calculating the distance, then do not write units as centimeter, millimeter or something like that, because they are not mentioned. These points are placed where on which type of graph paper. Hence your final answer will be in units. If area is asked somewhere, one question is there where you have to find out area In area, you will write down square units. Remember why I'm saying you have to just write down units, because that graph paper is which graph paper we do not know, centimeter, millimeter, meter. Hence, we will just write down units as units, and if it is area, that will be square units. We shall understand section formula using one of the question. I am taking question 1, sub question 2 from exercise 13A. If you read the question from the textbook, you will be able to see the coordinates of point A are given as -4, 6, B as 3, -5. A ratio in which the points divide is given to us as 3:2. This part M1:M2 is not given in textbook as a ratio, but you know in the formula we are going to use it as M1:M2. The point which whose coordinates we do not know, there is one point on segment AB and we do not know its coordinates, so I am going to label it as x comma y, and name of the point is point P. Let P x comma y be the required point which divides segment AB in the ratio 3:2. Before going into the question, I will, for our understanding, I will label this as x1 comma y1. Another point I will label it as x2 comma y2. Why I am labeling as these numbers? You remember the formula. What is the formula? You have to mention always bisection formula blah blah blah, like this. Fine. What is the formula? M is equal to M2 x1, or rather we'll go standard way, M1 x2 plus M2 x1 whole divided by M1 plus M2. Same thing as applicable for y. I'm just explaining you the x coordinate, how to calculate. M1 represents 3, so I'll write down 3 into x2 represents 3, M2 represents 2, x1 represents -4. You have to be very careful in signs also. Sometimes due to sign you may lose your marks. The ratio is 3:2, so M1 plus M2 will be equal to 3 plus 2. Now I know 3 3s are 9, 9 minus 8 over 5. So x coordinate is 1/5. Similarly, you can calculate coordinate of y coordinate of point P, and then you can just write the final answer. Few minutes back we understood the meaning of bisect. Bisect means to divide into two equal parts. New terminology what you are going to learn is called as trisect. Trisect, dividing into 3 equal parts. Now say I am having one segment AB, right, and I want to trisect it. Remember, I cannot trisect it with the help of only one point. If I want to divide or bisect it, I require one point to bisect it. But if I want to trisect, then I have to have 2 points. These are the 2 points P and Q which trisects segment AB. If I say points P and Q trisect segment AB, that means AP's length will be equal to PQ's length will be equal to QB's length. What I mean to say in simplified language, if this is 90 centimeter, then this will be 30, 30 and 30. In short, the ratio if I want to take, then it will be, if I take in the form of a ratio, then AP is to PQ is to QB will be equal to 1:1:1. All 3 parts are equal. Therefore, the ratio of each part to other part will be 1:1. I have taken 3 parts, so 1:1:1. Now, simple thing from this, if I want to know what is AP is to PB, it's pretty simple. AP is 1 part, PB is 1 plus 1, 2 parts, so AP is to PB is 1:2. If somebody asks me, sir, what is AQ is to QB, then I have AQ, 1 part plus 1 part, that is 2 parts, is to 1 part. So there is a meaning of trisection. Whenever they say that a segment is trisected, that means there will be 2 points, and whatever question arises out of this, you can solve it easily if you know the section formula. So remember, trisection requires 2 points that will divide this given segment into 3 equal parts. After understanding trisection, we will understand 5 equal parts. Here segment AB is divided into 5 equal parts, and for making this 5 equal parts, I have made use of 4 points P, Q, R and S. Point P, Q, R and S divide segment AB into 5 equal parts. That means if I want to take the ratio of each small part with respect to other small part, then it will be AP is to PQ is to QR is to SB will be equal to 1 is to 1 is to 1 is to 1 is to 1, right? Using this, if somebody asks me, sir, what is AP upon PB, then I leave up to you. What will you write it down over here? If somebody asks you what is AQ upon QB, it's pretty simple. AQ upon QB. AQ is made up of 2 parts, so it will be 2. QB is made up of 3 parts, so it will be 2 upon 3. And likewise, whatever ratio you want to find out, you have to find out. But the most important part is this, that each of the small part taken ratio in the form of a ratio, then it is 1 is to 1 is to 1. I'm talking, when I say small, means I'm talking about the smallest part. Fine. Now, based on this particular concepts, there are quite a few questions, and let me tell you, let me remind you, before you start with the exercise, you should know that whenever I say point P is on x-axis, point P is on x-axis, then its point will be its coordinates will be a comma 0, a some number, and its y coordinate will be 0. We have seen at the start of the lecture that whenever point is lying on an x-axis, its ordinate will be 0. Suppose point Q is on y-axis, then what can be your conclusion? It's pretty simple conclusion. Its coordinates will be 0 comma b, where b is some real number and other than 0, and this is its x coordinate, or the abscissa is 0. If you remember this many things in this particular exercise, that is more than enough.